students, welcome to this chemistry digital class. Hope so you have enjoyed your Diwali holidays and you have re-energized yourself to enjoying these digital classes. So let's start today's topic. So welcome to chemistry digital class. Dear student, as you know that we are doing the chapter 5 and we are almost in the of this chapter. So today I'm going to tell you about this last topic. Okay, so let's start. The topic name is periodicity properties of modern periodic table. Dear student, we have studied about the history of periodic table, how classification of elements has done. As per his classification, he classified the element on the basis of its atomic mass, in which the atomic mass of first and last, the average of these first and last atomic mass will be the average of second mass. Okay, then after that his limitation will be recovered by John Newlands. According to John Newlands, he classified the element on the basis of musical note, that is sa re ga ma pa dha ni sa. So in which every eighth element have similar property like the first element in 1864. Then after that Luther Mayer, which is not in your syllabus, but Luther Mayer also contributed to classify the elements. Then Dmitry Mendeleev, he is known as the father of element, and he is most famous and I can say the most contributory scientist who have classified the element on the basis of its groups and periods. According to his, there are 8 group and 6 periods were there, but the idea that we got, that is from Henry Moseley classification, that is called modern periodic table. Okay, so after doing this, now we studied in the last topic, in our last video I told you about the modern periodic table, in which we studied that the modern periodic table in 1913 Henry Moseley showed that atomic number of an element was more fundamental property than atomic mass. So this was the first classification where the base of classification is atomic number instead of atomic mass. And all the earlier elements, these all classification was on the basis of atomic mass. Because of that, these are failed, and this is on the basis of atomic number. The property of element are the periodic function of their atomic number. So modern periodic table, it consists 18 groups, 7 periods, that you know very well. Though through the modern periodic table, the position of isotope is clear, position of nickel and cobalt is clear, position of hydrogen is well explained also. So if we will talk about periods and groups, so according to modern periodic table, the trends in period and trends in groups, that we need to understand. It is very important to understand. So first let's talk about the periods, how periods form. Periods are horizontally rows of element in a period table is called periodically. There are trends, valency of electron. It means that from left to right, number of valence electron increases. If we will talk about period, okay, left to right. You know very well, when last time we did this modern periodic table, so we studied that there are some lines and there are some columns. Columns are called groups and lines are called periods. So these lines, along the lines, when we will move left to right, the valence electron will increase. Atomic number from left to right, there is consecutive atomic number like 1, 2, 3, 4. Valency from left to right, valency increase first 1 to 4, then it decreases to 0. Atomic size, it decreases from left to right. Metallic character decreases from left to right. Chemical reactivity, it also decreases from first decrease then increase. The nature of oxides from left to right, it is basic character which decrease, then acidic character increase. What do you mean by these increasing and decreasing, dear student? See, if we will talk about a periodic table, so this is group periods 1, 2, 3, 4, 5, 6, 7. So 7 periods are there down the group, and these are 18 groups. Okay. If we will talk about these 18 groups, these are toward down. These are 18 groups. There are 18 columns, and the 7 periods are there. These are 7 periods. Now what will happen to valency? If valency of hydrogen, we will say, the valency of hydrogen is 1. Valency of hydrogen is 1. Valency of helium is 0. Valency of lithium is 1. Valency of beryllium is 2. Then valency of boron will be 3. Valency of carbon will be 4. So valency is increasing when we move from left to right. and decreasing from it will remain same from top to bottom. If we are talking about periods, so this is, I am telling, the comparison of these element with each other. Their left, this is the right side. Okay, comparison of these element, comparison of these element, comparison of these element. These all elements are somewhere, we are talking about these elements. So down the group when we will talk, that time it is. So similarly in groups, what is happening? The valency group is vertical column. 18 groups are there. There are 18 groups and 7 periods. So vertical balance, it have same number of valence electron. If valency, we will say element in a group have same valency. Atomic size increase from up to down. Metallic character on going down, metallic character is increasing. Chemical reactivity is also on going down. Chemical reactivity of metal increases. Nature of oxide have same nature of oxides according to group. Okay. So next is modern periodic table. In the modern periodic table, elements are arranged in increasing order of their atomic number in the form of table which have 7 horizontal row element which is called period and 18 vertical row which is called groups. Periods, there are 7 periods of element. First period has 2 element. There is hydrogen and helium which is called very short period. Second period has 8 element, lithium to neon which is short period. Third period have 8 electron, 8 element, that is sodium to argon, called short period. Fourth period have 18, fourth and fifth period have 18 elements which have potassium to krypton and rubidium to xenon. These are called long period. Sixth and seventh are the longest period which have 32 elements, whereas seventh period is incomplete, it have only 28 element, and these are called incomplete periods. 14 element each of the sixth and seventh period are placed separately at the bottom, which is called F block, that is lanthanide to lutetium is called lanthanide, and 14 element in 7th period are actinide to lawrencium, this is actinide. Okay, so groups, there are 18 groups of element divided into 9 main groups. There are 1 2 3 4 5 6 7 8 0 group. The group 1 to 7. Okay, so basic properties, if we will talk about, basic property, we will talk about first basic property is valency. Just know what is valency. In a period, the number of valence electron increases from 1 to 8 from left to right in the number shell. Like for example, if second period member is there, that is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. So you know very well atomic number is 3, 4, 5, 6, 7, 8, 9, 10. Electronic configuration is 2 in K, 1 in L, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, 2, 8. So that is valency. Here 1 electron in outermost shell, here 2 electron, here 3 electron, here 4 electron, like this. These are valency. So 1 to 8 are valency, and there are 2 shells, K and L shell. Okay. Whereas in a group of number of valence electron in the same for all the element, what the number is shell increases from top to bottom. Hydrogen, lithium, sodium, potassium, it is group. The valency will remain same, and shell can be increased. Because of that increase in shell, the atomic size will increase. Now valency, if we will talk about valency, lithium have 1 valency, beryllium have 2 valency, boron 3, and carbon 4. Now although it is increasing, but now after carbon there is decreasing. 3, 2, 1, 0. Valency is totally depending upon the number of electron donating. It means that it is donating 2 electron, it is donating 3 electron, it is donating 4 electron. Similar way, it is gaining 3 electron. Okay, so mean up to carbon, the electron is donated by these element. Carbon have tendency to donate as well as gain, that we studied in previous chapter. And nitrogen, oxygen, fluorine, neon have tendency to gain electron. Okay, so these are valencies, and in a group the valency will remain same. Balance and valency, there is difference. Okay, now modern periodic table, if we will say in modern periodic table we are talking about valency. So dear student, valency is what? It is already I told you. If we will talk about this group, the valency of this group is +1, because 1 electron is there in outermost shell. Valency of this group is 2, valency of this group is 3, valency of this group is 4 and -4, then -3, then -2, -1 and 0. But if we will talk about valency of this and this, so this is along the period, it will increase first up to 4, then it is decreasing. Okay, now second Next periodicity property is atomic size. Atomic size, down the group atomic size will increase. As you can see here, lithium size, compare lithium size with cesium size, it is increasing. Beryllium size with barium, so it is increasing. Why it is increasing? Down the group along the column it is increasing. Why it is increasing? Because it is increasing with the increase in number of shell. With the increase in number of shell, you can see here hydrogen have 1 shell, lithium have 2 shell, sodium have 3 shell, potassium have 4 shell. It means that with number of increasing the shell, the atomic size will also increase. Then size of atom tend to decrease across the period, or along the group size will increase, whereas along the period size will decrease. Why size will decrease along the period? Because the increase in atomic nuclear size. Okay, see here, it is decreasing. Here size is big, their size is small. Size is big, size is small. Whereas down the group, size is small, size is big. It means that this size and this size is the bigger size. Okay. Metallic property, very simple. First, you have seen in periodic table. Periodic table is somewhere like this. It was somewhere like this. So you see, up to this there is metal. It means that metal is this side. Okay, and non-metal are this side. So metallic character is decreasing when we will move from left to right. Okay, metallic character is decreasing from left to right. Very simple. Sodium, if you talk about third period, sodium, magnesium, aluminum, silicon. Up to this there is metal. You can see here sodium, magnesium and aluminum are purely metal. Silicon, phosphorus are metalloid. Sulfur, chlorine, argon are non-metal. It means that in a period metallic property of element decrease from left to right. Okay, and in a group the non-metallic property of element decrease from top to bottom, or in a group the metallic character decrease. It will non-metallic character decrease, mean metal will be, non-metal will be on the top, then down metal will come. Whereas here this side, right, left side metal is there and right side non-metals are there. Then conclusion. Overall conclusion, the non-metallic character, it is increasing. Sorry, non-metallic character is increasing from left to right along the period. Which sign is this side? That is along the period. More negative electron affinity is also increasing. Ionization energy will also increase. Whereas atomic radii is decreasing and metallic character is also decreasing. Whereas same thing, red color you will see atomic size is increasing, metallic property is decreasing. Similar way, ionization energy is decreasing, negativity is also decreasing left to along the period, and non-metallic property also decreasing. Okay, so recapitulation, dear students, we have studied that Dovenier, the classification of elements started from Dovenier classification. From there, then Newland's octave, then Mendeleev periodic table, and then modern periodic table. Then we talked about modern periodic table. Modern periodic table is somewhere. First we started from here, then this, then this, then this. After studying this, we came to know the modern periodic table is the exact type of periodic table which gives us complete information, and this table is framed on the basis of atomic number. Okay, so there are 4 blocks: S block, P block, D block, F block, which made column, 18 column, and K, L, M, N, that make 7 periods. Okay, then after this we have studied that the S block have 2 block, basically first 2 group 1 and 2, which is alkaline earth metal and alkali metal and alkaline earth metal. D blocks are called transition elements, P block are called representative element, F block is called inner transition elements. So more information if you want to know, then you can watch previous video. Okay, now this is all about for today. So stay home, stay safe, stay healthy, dear student. This is all about of your syllabus. Now syllabus of chemistry is finished. Now tomorrow you will get exercise, and with this the syllabus is completed, and everybody has to, all of you have to complete your syllabus, complete your exercise, and after that we are going to start our revision. Okay, so thanks for watching this video. Thank you very much. Have a nice day.